I want to discuss about sum question chapter motion. Page number 100, question number 2. A farmer move along the side of a square field whose side is 10 centimeter. 10 meter. Whose side is 10 meter. He covered in one round 40 seconds. If farmer covered distance in complete one round 40 seconds, what will be the displacement if he move 2 minutes 20 seconds? So what is displacement? Displacement is the minimum distance between initial and final position. If after 2 minutes 20 seconds to the same position, then displacement is 0. If at D, then displacement is this. If at this, then displacement is this. If at C, then displacement is this. So displacement is the minimum distance between initial and final position. So now here side of the square field is 10 meter, perimeter of square field is 40 meter. Time taken in one round, complete one round equal to 40 seconds. Now 2 minutes 20 seconds equal to 140 seconds. 40 second distance, 40 second equal to 40 meter, that is one round. 1 second will 1 by 40 round, and 140 second number of round will get 3 whole of 1 by 2. Here in 40 second equal to 40 second distance equal to one round. 40 second, that is in complete one round take 40 seconds. So 40 second equal to one round. 1 second equal to 1 by 40 round. 1 by 40 round. 140 second, how much round taken? 3 whole of 1 by 2, that is 3 complete rotation and half rotation. Half mean the position at C. If we this half, then perimeter of half equal to this. So displacement is the AC. Applying Pythagoras theorem, we can AC square equal to AB square plus BC square. We can find AC equal to 10 root 2. So this is how to solve the problem. Farmer move around the boundary of a square field. Length of the square field 10 meter. In complete one round, he take 40 seconds. If he move around the boundary of the square field in time 2 minutes 20 seconds, what will be the displacement? This is the question. So displacement is the initial and minimum distance between initial and final position. This is the question number 2, page number 100. Page 103, question number 2. A bus decreases speed from 80 km per hour to 40 km per hour in 5 seconds. Find the acceleration. Here initial velocity equal to 80 km per hour, convert into s time in seconds, so it convert into meter per second. This is the conversion of meter per second. 80 km per hour equal to this by this meter per second. 60 km per hour equal to this meter per second. Change of velocity, acceleration equal to change of velocity, that is acceleration A equal to B minus E divided by T. So change of velocity divided by time, ultimately it is minus sign represent it decreases the speed. 103, question number 3. A bus starting from rest acquire a velocity 40 km per hour. After 10 seconds, what is the acceleration? So initial velocity equal to 0 as bus starting from rest. If starting from rest, then initial velocity equal to 0. If come to rest, then final velocity is 0. Final velocity is kilometers per hour converted into meter per second. time will 10 minutes equal to 600 seconds. Acceleration equal to b minus u divided by t. So ultimately concludes I solve this problem 0.0185 meter per second acceleration b minus u divided by t. Page number 9, question 1a. That is, a bar starting from rest move with a uniform acceleration. Here acceleration given, time is given. First you have to find the final velocity. So acceleration starting from rest, initial velocity equal to 0. Acceleration is given, time 2 minutes equal to 120 seconds. Find the velocity. We know b equal to e plus at. Initial velocity is 0. So ultimately it is 12 meters per second. In second b, find the distance. S equal to ut plus half at square. We put the value and find 720 meters. This is the distance. Page number 110, question number 2. Initial velocity 90 km per hour. We convert into meter per second. 25 meters per second. Bus come to rest. That is, here given brake apply, produce uniform acceleration, and brought to rest. Here brought to rest. So it is final velocity is 0. Final velocity brought to rest means final velocity b equal to 0. Brought to rest, acceleration is given. Find the distance. Twice s equal to b square minus square. Ultimately distance is fine. Ultimately distance is fine. And question number 3. Here acceleration is given. Initial velocity equal to 0. Time is 3 seconds. Tune the velocity after 3 seconds. We know b equal to e plus at. From this we find the acceleration. Number 4. Acceleration is given. Initial velocity is 0. Starting from rest. Time is 10 seconds. Find the distance. S equal to ut plus half at square. So distance equal to 200 meters. Question number 5. Follow this one. A stone is shown vertically upward. Initial velocity 5 meters per second. Acceleration minus 10 meters per second square. As upward direction, so acceleration decreases. So it is negative sign. Highest point. So you find what is the highest point reached. Height stone thrown vertically upward. So this is the top point. Final velocity b equal to 0. When again back after 10 seconds, after 10 meters per second square. What will be the height attained? Height will be, we know twice s equal to b square minus square s. What is the? So 1.25 meter. And height, what will be the time taken? We know b equal to e plus at. Acceleration is given. So time equal to 0.5 seconds. This is like that of 101 problem. And athletes move around a circular path, diameter 200 meter. What is the perimeter? So diameter equal to 200, radius will be d divided by 200 meter. The perimeter of the track 2 pi r. This is. Now let the athlete at the point at this is the position of A. He start moving down the how much displacement after 2 minutes 20 seconds. 2 minutes 20 seconds equal to 40 seconds. So distance covered in 40 seconds equal to this. Distance covered 140 seconds distance covered by this. So number of round equal to total distance divided by distance in one round. So is half. Half mean diameter. Half mean if we round this track and starting from A and come back to A, then displacement is 0. If at that point, then displacement is this. If at that point displacement is this. Half mean this is the complete 3 round and half. So it is a semicircle. So this is the position. So displacement is the AB. So AB is the 200. So displacement of the AB, displacement of the atlas is 200 meter. Person move from A to B and then B to C. First cases, find the average velocity from A to B. Average velocity, average speed mean distance divided by time. So distance is the A to B distance will 300 meter. 300 distance divided by time. Time taken will give what is the time? 2 minutes 30 seconds equal to 150 seconds. Distance divided by time. This is the average speed. Average velocity, speed will distance divided by time, and velocity will displacement divided by time. Velocity is the displacement divided by time. Remember that velocity is the displacement divided by time, and speed is the distance divided by time. So A to B distance, average velocity and average speed are equal. But in case of B, when back to C, then distance is a AB plus BC, but displacement is only AC. That is 300 minus 100 equal to 200 is the displacement, and 300 plus 100 equal to 400 is the distance. So ultimately we find this average speed and average velocity. In this case, second case B, distance is a 400 meter and displacement is this is the displacement, minimum distance between initial and final position, that is AC is the displacement and AB plus BC is the distance. This is the point. Find the average speed is to find the time for going. If x is the distance divided by speed, is the time is the distance divided by speed. For second cases, also distance divided by speed. In both cases, we find the time. To and from motion, this is on going and this is on returning time. On going speed 20 km per hour and returning 30 km per hour. This is the total time taken. Total distance x plus x. Total distance twice x. This ultimately we can find the average speed. Average speed ultimately we can find. Number 4. Also find the distance s equal to ut plus half at square. Starting from rest, u equal to 0, acceleration is given, time is given. So you find the distance traveled by an object, 96 meter.